Okay, guys. So we are live now. एक बार messages में you can ping that we are live. So you can hear me, so that we know that you are here and we can start learning some containerization, virtualization, and Docker. Now these days you are hearing a lot about cloud. So today is the time. आज हम देखेंगे reality में what exactly the cloud is, how exactly we can understand how exactly everything is happening behind the scene in things. Okay, so show me some enthusiasm. Show me some enthusiasm. How exactly you want to learn these things? Yay! How's the Josh? How's the energy? Tell me, how's your energy? And also tell me if the voice is clear and everything, so that we do not have any voice issue and noise issue. And एकदम जोरदार तरीके से हम चीजें शुरू कर सकें. Yay! Just one second. Just one second. Yo, so if we talk about cloud, what do you understand by it? क्या होता है cloud? Generally, there was a guy, a politician, some time back, when he was interviewed, कि cloud क्या है? What is cloud? He said that ठीक है, cloud technology ये सब जो हो रहा है सब अच्छा है, but what if we store all the data in cloud in about Aadhaar card and everything, and what if it rains? Now, how exactly we will know about the data that is on the cloud? You can realize how stupid that might sound, but it's like this guy do not have any idea about what cloud is. But what if I ask you what is cloud? That guy don't know what cloud is, but do you know what cloud is? Do you know what exactly this thing mean, what it can do, what it is about? If you know anything about this, if you know something good, or you can just put in one or two line in the comment box, so that I know that you know. Okay, so a lot of people think that cloud is about data. So why that is wrong? Why cloud is not just cloud storage? Cloud is about cloud storage, cloud computation, and a lot of things. So how exactly you determine what cloud is? 3D Bhavya is like Badal. Cloud refers to the server that are run on internet. So how exactly cloud is different from dedicated servers? If you are saying that cloud is just server only, then how exactly cloud is different from servers? फिर सेम ही बात हो जाएगी. If we say that cloud is just servers running on somebody else's computer, then servers is like shared computer only. Okay, then cloud is a shared servers only. But how exactly it is a bit different. So Ananya says, Puji says data center, server, compute, and store data over internet. Okay, so kind of it is data center. Yeah, so cloud is kind of data center. But in case if we talk about dedicated server, so do we consider dedicated servers into? Do we consider dedicated servers into cloud? That is one of the questions. Okay. So just one second. Let me share my screen as well. 1 second. Right now. Just one. No, not right now. Just 1 second. Okay, let me change it. Change the sheet. Reading the notebook. Cloud is nothing but yeah, it's kind of a thing, but it is not exactly the thing. ओके, सो कंप्यूटर जी स्क्रीन शेयर कर दीजिए। डन, everybody is able to see my screen now? Okay, awesome. So now what we want, हमारे को देखना है क्लाउड के बारे में, ठीक है? तो क्लाउड के बारे में जब बात समझना शुरू किया, सो व्हाट वी वांटेड कि हमारे पास में यहाँ पे जो सिस्टम है, द सिस्टम दैट वी हैव हियर, we should be able to access these items, whatever we used to do with servers is what provide the services, and client is which put a request. Okay, server is what provide the service, सर्वर जो सर्विस दे रहा है, एंड क्लाइंट इज जो सर्विस ले रहा है, ठीक है? क्लाइंट ने रिक्वेस्ट मारी, सर्वर ने रेस्पॉन्स कर दिया, एकदम बढ़िया, एकदम जबरदस्त, कोई इशू नहीं है इस केस में, ठीक है? बट व्हाट इशू अराइजेस इज दैट कि जब यहाँ पे हम डेडिकेटेड सिस्टम के बारे में बात करते थे, जब हम डेडिकेटेड के बारे में बात करते थे, तो हमारे को बहुत बड़ा इशू आ गया। एंड व्हाट वाज द इशू विद डेडिकेटेड? दैट वी कैन नॉट स्केल देम। Okay, we do not have these kind of possibility like scaling and these kind of things. So for that we need something different for scaling and these kind of steps. So uske case mein what we wanted to make the cloud system, that we want some individual small units, some small virtualizations that we can scale up horizontally, okay? So there are two kind of scaling. If we scale in two dimension. Either we scale vertical or we scale horizontal. Okay, so vertical scale is what? कि मेरे पास में let us suppose 4 GB system, 4 GB RAM है, and if I increase it to like 16 GB RAM, this is what? This is vertical scaling, that you have one system, but you are scaling its capability to work more on the same system itself. This is what? Vertical scaling. But when we talk about horizontal scaling, that we had one system of 4 GB RAM, 4 GB RAM, and now we have 4 systems of 4 GB RAM. Okay, so obviously this should also provide more capability to you, and this should somehow, your code should be something like this, so that this kind of system provide you better output, even if better than this. Okay, so how this kind of system के मतलब चार के चार system, how can these be better than this one? ठीक है, तो सबसे पहली चीज आती है कि जनरली व्हेन यू कंसीडर 4 GB रैम के 4 सिस्टम, द मोस्ट इंपॉर्टेंट रैम कंजम्पशन यू नो थिंक ऑफ कि यार चार के चार अच्छे क्यों नहीं रहेंगे? व्हाट इज द प्रॉब्लम विद दैट इज ऑपरेटिंग सिस्टम कितना कॉस्टली है, इजंट इट राइट? जनरली व्हेन यू से कि यार 4 GB के 4 सिस्टम लगा देंगे, व्हाट इज द प्रॉब्लम विद दैट? 4 GB 4 सिस्टम, व्हाट इज द प्रॉब्लम विद दैट व्हेन यू थिंक ऑफ दैट? No, you will consider that yeah, 8 GB, 1 or 2 GB is consumed by the operating system itself, and how do we stop that? ये बात सही लग रही है गलत लग रही है, बता दो फटाफट। ठीक है, it is more expensive because we are consuming a lot of resources for the operating system. But what if we can reduce that? If we can reduce operating system cost, if we can reduce that, if we can say that 100 MB RAM is enough, then what is the benefit of putting more system than one system with higher capability? Okay, what do you think of that? One system or more system? 16 GB, you're thinking of 16 GB system, 16 GB one system, or 4 into 4 GB? इसमें कौन सा वाला चूज करोगे? ठीक है, एक सेकेंड, थोड़ा सा गड़बड़ लिखा गया, 4 into 4 GB, ये वाला, this is option 1 and this is option 2, 4 into 4 GB. Which one you will choose if operating system takes only 100 MB RAM? एक बार ऑप्शन सभी पुट कर दो एक बार फटाफट, इतना पानी पी लेता हूँ, and then we will discuss कि why, which one will be better. So a lot of you think right now कि ये वाला better होगा. And now what will I say? एक बात को सोचना कि option one तुमने बोल दिया कि this one will be better. But initially when I was talking about that guy who said that cloud is like what is in the sky, you are like that guy is an idiot. But now you also do not know enough about the cloud and in these kind of computation, because you have very limited thought about what your operating system, what your computer does. Generally you do not prefer 4 computers, you prefer 1 computer. But when we talk about the server side system, we do not have a limitation that कि 4 को होगा तो manage कैसे करेंगे and these kind of thing. Okay, for these kind of things you can have a different kind of thought. How? एक बार सोचते हैं. सबसे पहली thing, the first thought is high availability. High availability. Okay, so if we talk about the server system and we talk about high availability, and high availability is like that, even if you take the world's best system, it have to be repaired or upgraded at some point of time. Make sense? कि तुम्हारे को फाइनली अपने ऑपरेटिंग सिस्टम में जो भी तुमने कोड डिप्लॉय किया है, एट सम पॉइंट यू हैव टू चेंज दैट कोड, राइट? सभी को बात सही लग रही है? तो अगर तुम्हारे को वो चेंज करने की जरूरत पड़ेगी तो फाइनली यू विल नीड टू टेक डाउन दैट सिस्टम फॉर फ्यू मिनट्स. ठीक है, अब लेट अस सपोज the whole Google work on a single system and then that system collapse because of some reason. What will happen? Pura Google, there was a system of 1 terabyte RAM or 100 terabyte RAM, and that system collapse. How bad that will be for the whole, whole, I will say world, कि पूरा Google गया, मतलब 5 मिनट पे 10 मिनट के लिए 1 घंटे के लिए पूरा Google डाउन है पूरे वर्ल्ड में. लंका लग जाएगी भाई. that will be too bad, right? So but if you think of this kind of system कि जहाँ पे हमारे पास पे we have horizontal scalability. So मैंने थोड़ा बड़ा एग्जांपल दिया है कि bigger example so that you have a better understanding how actually things flow. But if I talk about in a smaller constraint, if I talk about your website, let us suppose you are building something and you say that I want this kind of system where we have horizontal scalability so that I have 4 small system, and at one point of time if I get 1,000 requests, they are divided into 4 parts. So first thing is even before high availability we have more cores. Okay, now we have more cores. Okay, so because of that पैरेलल प्रोसेस हो पा रही होगी, पैरेलल चल पा रही होंगी चीजें, ज्यादा पैरेलल चल पा रही होंगी. दैट इज फर्स्ट बेनिफिट. देन सेकंड बेनिफिट इज हायर अवेलेबिलिटी, बिकॉज if one system goes down because of the load balancing and these kind of instruments, now you can have more system to redirect your data. That if we get a request now, if we have 4 nodes, if this one is down, we can distribute the whole load into these 3. Okay, so because of that we will be having better possibility of availability. Okay, so this kind of system is better in this horizontal scalability. Sense बनती है इस चीज की. So if these things are considered, and I will consider even more things. ठीक है, I will go to slides now so that we can have a more structured instruction to you. मगर अभी हमने पहले थोड़ा सा general viewpoint लिया so that when we open slide you are more comfortable with the content. You don't feel like कि exactly यार डॉक्टर होता रहे मगर ये हो क्यों रहा है. तो generally when I said that you will be consuming less RAM to create more systems, so that is where where Docker comes in. Probably you have heard a lot about Docker these days. तो Docker के बारे में तुम्हें कितने लोगों ने कितना सुना है? Have you heard कि यार ये कोई बहुत तोड़ चीज है या फिर don't know anything about that? There's one question from Deepak Sharma. Can you please highlight that? So Deepak Sharma is saying that then why vertical scaling? Vertical scaling की requirement ही क्या? ठीक है. So just think of this. Why not every time you can do horizontal scaling? Probably if you have a machine learning model or something like that, which on the single process itself, where parallel things are not happening, where single instance need more RAM. Okay, where you cannot divide the work into multiple tasks. Your individual task is taking that much of resource, where you need, in that particular case, you will be needing vertical scaling. There, horizontal scaling is not helping you. ठीक है, अगर लेट अस सपोज तुम्हारा गेम है and that game need approximately maybe 10 GB to run. Can you say that इस गेम को मैं 4 सिस्टम में तोड़ तोड़ के चलाऊं? Just think of it. Can you say that I have this game which consume 10 GB RAM, but my individual processor, individual system take only 4 GB RAM, so I will run this whole application divided into 3 systems. So it is very difficult to divide a particular game into 3 systems, but it is particularly easy to divide a web service where we can have, okay, database will run here, this thing will run there, this thing will run there. So in that particular case, we can have a simpler architecture. Make sense? ठीक है, ये बात सभी को समझ में आ गई, सभी को सही लग रही है? ठीक है, if it is okay for everybody, okay, तो उस केस में तुम बोल सकते हो कि let's move forward to understand this thing. मस्त, सही है, ठीक है, बढ़िया. Okay, so if this thing is fine, so we will talk about what exactly Docker is, and then we will move to slides. Okay, so Docker ने केस में क्या कर दिया? We said कि हमारे को 4 GB systems बनाने हैं that consume very little RAM for running the operating system. But if we do not have operating system, how exactly we gonna run these kind of systems? Okay, so for that, and especially in case of when we talk about data centers, उस केस में हमारे पास में क्या सेंस आएगा? व्हेन वी टॉक अबाउट डेटा सेंटर्स, 4 GB रैम के प्रोसेसर, 4 GB रैम के सिस्टम्स बनाना बहुत महंगी चीज है. देयर यू नीड कि तुम्हारे पास में 100 GB, 200 GB, 1 TB रैम के पूरी पूरी ट्रेस क्रिएट हो. ओके, वी वांट अ ट्रे ऑफ मे बी 1 TB रैम. ओके, इफ यू हैव 1 TB रैम but you want instances of 4 GB RAM. That is funny. How do we do that now? And we want individual instance to only consume 100 MB RAM for individual operating system. So in this particular case, we have to understand about virtualization. Okay, so what is virtualization? For virtualization, you can understand virtual machine से भी ना चलाइए, ठीक है. वर्चुअल मशीन से अपने लैपटॉप में सभी ने चलाई होती हैं, ठीक है, कि मतलब विंडोज चला रहे हैं, पैरेलल में उबंटू डाल दिया, एंड दिस काइंड ऑफ थिंग, दैट यू आर रनिंग अ वर्चुअल मशीन in Windows, you are running maybe another Windows or Linux or something like that. ये चीज सभी ने करी है, देखी है, सुनी है. This is comfortable for everybody. और Oracle का वर्चुअल मशीन है, राइट? और भी काफी सारी तरह की चीजें जो तुमने देखी होंगी, सुनी होंगी. यस यस यस, बढ़िया, ठीक है. तो सभी ने वर्चुअल मशीन्स देखे हैं, बट व्हाट इज द प्रॉब्लम विद वर्चुअल मशीन? दैट दे कंज्यूम quite good amount of resources. So if we talk about this kind of system, what you initially used to happen, that you kind of used to have 1 TB RAM tray, but you used to divide, virtual machines over it. And those virtual machines used to run the individual instance of the people. Okay, but this one system में issue क्या है? When we talk about virtual machine and these kind of divided systems, that you cannot really run the whole operating system in 100 MB RAM itself. So you are consuming more of resources. ठीक है, you'll be consuming more resources. एक सेकंड, ठीक. Okay, so if this kind of thing is comfortable for you, you understand this thing that okay, we have 1 TB RAM, उसमें हमने 4 GB के चंक तोड़ने शुरू किए. But अगर हम virtual machines बनाते हैं, in that particular case we are consuming still good amount of RAM for the virtual machine itself. So we want to minimize that, and for that there came in the different concept of virtualization, that is containers. ठीक है, containers आ गए. अब containers ने क्या कहा? That we do not need your whole operating system stack. We do not need your whole operating system stack. We only need very small part of it. Just 1 second. Can you please mute me for a second? Just 1 second. I'll be back in a minute. Okay, so I'm back. There was a very small hiccup, and now we are back online. Okay, so we were talking about containers. So when we talk about operating system, there are a lot of resources that come into picture. That we have kernel, we have these kind of things. We will be soon looking into slides. But when we talk about containers, we only need the part of the system. Okay, so because of that, we'll be consuming less RAM. Okay, and these kind of things will be clear now when we take a look into these slides. सो बियर विद मी, ठीक है, थोड़ी चीजें तुम्हारे को कई पार्ट में थोड़ी सी एक्स्ट्रा लग सकती हैं, यू विल बी लाइक के यार दिस काइंड ऑफ कांसेप्ट्स आर टोटली न्यू टू यू, बट मजा आ जाएगा, ये बात मेरी गारंटी है ना, अनुज भैया की गारंटी है दैट यू विल लाइक दिस होल सिस्टम। ठीक है, इंट्रोडक्शन टू डॉकर, पूरा सिस्टम हमने देखना शुरू किया, आईटी लैंडस्केप ने क्या चेंजेस आए। ठीक है, पहले हमारे पास में कंप्लीट ऐप जो बनती थी दैट वाज on the dedicated system, but now what we have is that we have applications deployed on the cloud using DevOps। ठीक है, DevOps का नाम तुमने काफी लोगों ने सुना होगा, डेवलपमेंट एंड ऑपरेशंस। पक्की बात है, ठीक है, डेवलपमेंट एंड ऑपरेशंस वाला पार्ट आया, ठीक है, एप्लीकेशंस यू डिप्लॉयड ऑन द क्लाउड। ठीक है, तो उस चीज को समझने के लिए व्हाट वी अंडरस्टूड दैट वी हैव टू माइग्रेट आवर एप्लीकेशन टू द क्लाउड, एंड फॉर दैट वी नीड समथिंग वेयर you can easily transport your system। ठीक है, मतलब if you are running on AWS, you are running on G Cloud or anywhere, whole of the system remains same। ठीक है, and for that particular system there came the concept of microservices। ठीक है, एक बार माइक्रोसर्विस के कंसेप्ट को बड़े ध्यान से देखो तो ये हमने क्या कह दिया कि the whole monolithic application have been divided into smaller systems। ठीक है, ये smaller systems है तो हमारे पास में सेंस क्या बनता है that now we do not need this big system of 64 GB, like this kind of system. Just one second. System we do not need. We need these smaller systems which are running some smaller applications, and because of that we can have a better system। Make sense? ठीक है, तो हमारे पास में पहले सिस्टम जो था, we needed a bigger chunk which was monolithic, slow and big server, but now we have smaller servers running microservices। ठीक है, so if we have microservices, how does that provide us easier way of transport कि हम एक जगह से दूसरी जगह पे लेके आ सकते हैं। ठीक है, so for that we have to understand कि हमने finally अब क्या किया है, हमारे कोड के चंक को डिवाइड करना शुरू कर दिया, that we have maybe for some smaller sub services in the whole system that we are shifting into individual system। okay, let us suppose हमने क्या कह दिया कि फ्रंट एंड के लिए था, ये बैक एंड के लिए था, ये डेटाबेस के लिए था, एंड ये सब कुछ और लाइक ऑथेंटिकेशन पार्ट के लिए। ठीक है, so now if we have these kind of chunks, like we have front end here and back end here, okay, so we have created them separately, so now we have possibility of what, if we have these kind of division, then we have the possibility of scaling। and what is the possibility of scaling, that now we can have that do not give me one of this thing, do not give me one parallel, give me 10 parallel। okay, so it is more like what, that give me 10 servers of this front end, give me 20 servers of this backend, give me 100 servers of this like what it was, I don't database। okay, give me 5 servers of this authentication, and you may just chunk them around, you can connect them, and because of that it can create highly stable, highly available stateless system। make sense कि हमारे पास में क्या सिस्टम आ गया कि finally that thing that we had monolithic, now we can divide that and we can distribute that and we can have individual chunk scaled, that we want to scale the front end, we can do that, we want to scale the back end, we can do that, anything we want to scale we can totally do that very easily। ठीक है, तो इसका मतलब हमारे लिए पहली बात तो क्या हो गई, हमारे लिए स्केलिंग सबसे पहले आसान हो गई। ठीक है, दिस थिंग मेक सेंस टू एवरीबॉडी, सबको ये बात सही लग रही है, किसी को कोई दिक्कत तो नहीं आ रही है इसमें पर्टिकुलरली, एवरीबॉडी इज कंफर्टेबल विद दिस थिंग? okay, cool। So now if we talk about this thing, the second step that came in is okay, Palanipam. Okay, so please English. Yeah, so I will take care of that. So most of the concept that I'm teaching is in totally English. So people who are not comfortable with Hindi, make sure that you're not missing anything. It is just like when I kind of repeat something. Sometime I use a bit of Hindi just for making things fun. Some jokes of mine are in Hindi. And I cannot really translate them. So don't worry about that. Generally, the Hindi one are only jokes. That's it. Okay, so now we talk about this continuous integration and delivery. So what exactly happened in continuation integration and delivery? That now you say the whole system that you generated in this previous slide, we said that this application is now divided into smaller system. Just 1 second. Can you please ask the noise is coming? Yeah. Yeah. Okay. Cool. So this whole application is divided into some smaller subsystem, and now we want that if we change a code in this smaller subsystem, we can change the whole application by just simply pushing in the new system. Okay, so what we're saying that is we want to deploy the newer version of my front end into my whole system, and we do not want to change the whole application level. Okay, so for that, what we can do, we need something which can integrate and deliver by automatic process. So like we have your version control system. So you have your GitHub account and you push on your GitHub account and you pull, merge the pull request from the master. And now what you want is that after you merge your pull request on master, there should be a process. There should be a process of what? That your developer is pushing the code on master, and because of that, it is running some checks on your system that if every integration and everything is fine or not. This part is being observed by QAs, like testing people. And after everything is done, this person tells, okay, everything is fine, now we can deploy. Okay, so now this application goes for sysadmin. Okay, now sysadmin will say, okay, it is fine, and now we can go for production. But when we talk about CI/CD, this thing can whole be automated. That if all checks pass, this will tell here. Now sysadmin part is also have automatic process, and now sysadmin automator can simply deploy it on the microservices level. मेक सेंस? ठीक है, तो जब हमने यहाँ पे किसके बारे में बात करा, व्हेन वी टॉक अबाउट डेवलपर्स एंड आईटी ऑपरेशन पीपल, सो डेवलपर वांट दैट दे कैन क्रिएट इंडिविजुअल एप्लीकेशन एंड दे कैन पैकेज देम एज इट नीडेड. ठीक है, मेक सेंस? कि जैसे जैसे चाहिए वैसे वैसे वी आर पैकिंग एंड वी आर डिलीवरिंग द कंटेंट. But IT operations want that they can quickly and flexibly deliver things. Like if we want to package a few things and we want to connect them, we can easily do that. Okay. But what happens is that when developer have freedom, they create something which is not easily operable by operations people. Okay, so because of that, this microservice architecture where you are creating these smaller application which can be easily binded, this kind of system is easily convertible into the whole architecture. Make sense? कि यहाँ पे भी हमारे पास में the whole system will be better now. Okay, so there is a question from AMV World. Sir, VM is machine inside our PC. How our PC is cloud. VM can happen inside your PC, but it do not have to be inside your PC. Virtual machine can happen anywhere, wherever there is a computer, wherever there's a whole computing machine, you can have a virtual machine. Virtual machine is like a simulation of pure hardware to create a new operating system where you can have your individual applications, segregated applications, which are not totally on the operating system communicating with other applications of your base system. So like if you want to use a virus, if you want to kind of so let us suppose the virus kind of we had 2 to 3 years back, which was like disturbing ATM machines. So if you are testing on that kind of virus, will you really want to run it on your personal operating system, or will you try to use it on an operating system which can be easily disposed of and can be reinstalled? क्या सही लगेगा तुम्हारे को? Which one will you prefer? Your personal operating system or some replaceable system. So virtual machine क्या है? Virtual machine is that this replaceable system. That's it. Okay, and that can happen on your personal computer. That can happen on the server. That can happen anywhere. Okay, so virtual machine is simply that. Don't worry about it. Okay, so if that is fine, we can come back on this point that how exactly we can become better than these virtual machines. Okay, so when we talk about the base system and the virtual system, the base system, like the bare metal machine, is on-premise Linux traditional. But now what we have is like virtual cloud. In the slide we have written Windows because we made it for Windows system, but like the company it was using that, but we could use Windows or Linux or anything, whatever. Okay, so this kind of thing, you can do anything. Okay, so you can run Windows, Linux, MacOS, or anything. The kind of license you have, you can run it on these kind of virtual systems. Okay, and because of the microservices, they can easily communicate, and that's it. Okay, so now when we have the better version of this thing, now you can have if we say that these microservices, you can create better applications, and you can divide the traditional application into smaller chunks. So the kind of slides which are not very particular to this session, I'll be skipping over that so that we have better time for the hands-on part of the things. Okay, so this is the history of Docker, how things evolved, and how exactly in the 4 years we got these many hosts and Docker applications, and everything is like shifting to Docker right now for creating the containerized applications. So this is the history of Docker, and this is the yeah, it is fine now. Okay, now it is fine for everybody. So whenever there is a pause, we will get to know. Don't worry about it. This lag. Okay, just 1 second. Just 1 second. Okay. Yeah, so there was some internet issue because of the raining. So it is raining in Gurgaon, and we are in Gurgaon, so we have to bear up with a small thing. So yeah, so now it should be fine. Please tell if it is working fine for everybody now. It should be fine. Yay! So now we are totally fine. There is a bit raining issue, but that is totally bearable now. Okay, so we have application, and that is traditionally we have application which is running on the operating system and which is running on the physical operating system, physical server. But there is a very better version for that in case of virtual machines. And virtual machine does what? The kind of system that we were talking about, that in this 1 TB setup, you can create multiple virtual machine which will work on hypervisor. Okay. But what this hypervisor does for you is that it will create a virtual hardware. It will create a virtual hardware, and on virtual hardware you will be running your virtual operating systems. Let me change the color of the pen. Okay, so you'll be creating a virtual operating system and you'll be running your thing. So like, if you have, let us suppose you have 16 GB system, you have the 16 GB system, and on these 16 GB you have your base operating system that will consume approximately 1 GB. Then you have your hypervisor that will consume approximately 1 GB, and these individual operating system will consume 1 GB. So that is approximately 3 GB. So out of these 16 GB system, you have already wasted approximately 5 GB RAM. So do you really prefer these kind of things when you run your server? क्या सही में इस तरह की चीज पसंद आएगी कि मतलब इतना सारा सिस्टम आपने फाइनली यू हैव कंज्यूम जस्ट फॉर द सेक ऑफ रैम itself? ठीक है, तो यू डोंट वांट दिस काइंड ऑफ थिंग. ओके, सो I will not be able to provide notes for this thing, but I will provide you these slides, and I will be providing the afterward when we will be doing hands-on. We will be writing some code and changing some documents, so you will get those things as well. Okay, so but I will not be provided to the kind of changes that I'm writing on the slide. Okay. Can you provide me that ice box? Don't you're not being selfish. So I will add link to this slide in the description, in the description. Don't worry about it. You'll be having this slide in the description, but you'll not be having the things that I'm writing because it is on screen. So I'm not saving those screens. Okay, so that's it. Okay, so there were some benefits like rapid elasticity. You could increase your things comfortably, but there were some limitations like CPU allocation, storage, RAM, and these kind of things that we have already discussed. But when there came containers, and containers were beneficial because of what? That you do not need guest operating system in this system. Like what? When you have host operating system, you just have this Docker engine running, and because of this Docker engine, you can simply install additional application on top of that. Okay, so here you are having these kind of setup on this whole system. You do not have to provide the guest operating system for individual each and every virtual machine. Make sense? सभी को बात सही लग रही है? ठीक है. So you do not have to have this kind of thing. It is much more efficient in this particular thing. Okay. Okay, just 1 second. I know a little bit of noise will be coming in. That is because of rain. I cannot really do anything about it. So you will have to bear with me. Okay, so yeah. So now we do not have to have these guest operating systems. So if we do not have these guest operating system, then what we can have? Okay, so what we are having now is the speed, because individual creation of fake resources, those virtual resources, consume a lot of time. But we do not need that kind of time right now. Individual virtual machine take approximately 1 minute. Individual virtual machine takes approximately 1 minute to get up. Okay, but individual container take approximately 10 seconds to get in. Okay, and this is a huge difference when we talk about scalability. Okay, so if we are having a higher load on a system, like when we talk about IRCTC, when we talk about IRCTC, you get a huge load at 10 a.m. Okay, and you cannot really wait for minutes when you are trying to scale up your servers, like adding more instances of the application, so that now you are more capable of having a better load. Okay, you don't want that kind of system where you need that kind of time to scale. You want a system where you can scale in a very small amount of time. Okay, then there is portability because of the dependencies, because in individual each and every virtual machine you will need to install everything separately. But what containers does for you is that because of the layers that we will discuss soon, you do not have to set up the whole system in the virtual machine. You can simply say that this is the layer architecture that you have to follow, and because of that all of the application need to be installed of whole environments, environment variables, everything will be set up for you. Okay. There is a question from Anirban Day. What is the difference between container and Docker? So Docker is the concept. Okay, Docker is the whole tooling system that you have. But now, based on Docker, what I can say that I think it will come in the slide as well. But if we shift from here to here, just for you guys, what exactly is Docker, so that you have a better interest in understanding why we are learning those slides. Because of that only we were initially having the slide here. That is, Docker is a concept, Docker is a tooling system which is telling you if you want to create containers, you want images, okay? And images have layers, okay? This image is a blueprint, just like what? Think of जब एक second, when we do basic when we do basic programming, we think of class as blueprint. ठीक है, classes बनाते हैं and we say that class is a blueprint. Can you please remove comment from the screen? Thanks. Yeah, please remove the comment from screen. Yeah, done. Okay, so blueprint is like class we used to have. Okay, so like images have layers and the whole image is a blueprint like class. Then what we can say that image create containers. Image create containers like class create object. ठीक है, रिलेशन समझ में आ रहे हैं? That like from images, operating system images, we create containers. Like in basic programming, class is the blueprint that create object. So we can simply say that containers are instance of images, that those images individually have layers that we pull from the internet. Make sense? ये बात सही लग रही है सभी को कि हमने फाइनली चीजों को डिवाइड करना शुरू किया. The division is like the whole system. Like if we say that we have this Node 10 system, and this Node 10 system have some node installations, these have some basic dependencies pre-installed and everything. So we'll be having kind of 10-20 layers, and this base layer may be of like installation of Ubuntu. Then we have some changes over it, then we have some changes over it, then we have some changes over it. So what we are doing is that we are having these kind of layers that we can pull, and after we pull all these layers, we will be creating a whole image. Okay, after these layers we create a whole image, and because of that image we can create the instance of this, and we call it container. ये बात समझ में आ गया? So when we say what is the difference between Docker and container, we do not have any difference between Docker and container. Docker is one of the tool to maintain the images, and from these images you can create containers. ये बात सबको सही लग रही है? ठीक, everybody is fine with this thing now? Yeah, so we'll be creating lectures on data structure also as well. Don't worry for that. Okay, awesome. So if we are fine with this thing, we can move for the yeah, okay. So this was the next slide itself. Okay, so like we have images. So images like what? The basis, the most base structure of the thing which create the blueprint. Then we have containers. Containers are created part from image. Engine is what maintain all these images and containers and everything. Registry is the remote location. Registry is the remote location where you have all these, maybe, there are two parts, maybe. One is the local registry and one is the remote registry. So like you can say Docker Hub when we talk about on the browser. Let me create a new window for you guys. Uh, on the Docker, we have this Docker Hub. Okay, so this is one of the registry. Again, there is a local registry where you can have local containers and local images, where you are maintaining these images from where you can pull and push, like images that you want. Okay, what is a container? What container is the instance that I'm saying. If like these instances, like these horizontal instances we were talking about, 4 GB RAM, 4 systems, and these things. These are containers. Individual machine created by Docker is a container. AVM world, you are fine with this thing? This individual machine, this individual, we can say simulated machine. It is not exactly a virtual machine, but like simulated machine is a container. So container is like replacement for virtual machine, which is not separately having a separate operating system. It is just providing you the information like, okay, so this is the base operating system. Now you have separate installation of applications and you can use that. Okay. Suman, if you do not stop speaking that please make video on DSI and everything, we'll need to ban you from messaging. So right now we are talking about the system like Docker and everything. Please focus on that, and everybody please take a note on this. Okay. Okay. So now, uh, okay, but yeah, yes. So cool. So we have to understand now what Docker engine is. Docker engine is maintaining this whole thing, this network, volume, distributed state, container runtime, and everything. This whole system is provided with the Docker engine. Okay, and this Docker engine can really replicate the system. Okay, of we can say this Oracle virtual machine where we have these many virtual machine are being running on that. So this is the whole system that we can say that the Docker engine is. Docker engine is the place where you have volumes and everything. Okay. कंटेनर में मैं सर्वर रन कर सकता हूँ सर. Yes. So there is a very common question, what exactly a server is. ठीक है. It is a very very common question. What is server? ठीक है. Generally there are multiple level of consideration of servers. So you can say the bare metal. In the bare metal, the whole machine as server. Okay, this bare metal can be called as a server. Then this operating system, like we have rel, rhel, Red Hat Enterprise Linux, that is an operating system which is generally made for servers. So what you can say, this rel can be considered as a server operating system. But then you have these containers like I will say like Tomcat and everything. Tomcat and Wildfly. Generally, people call them server. Okay, but these are applications which eventually help you in running your code. So when you say that, can you run your server inside the containers? When we talk about that, we generally focus on this one. Okay, because when we say that it is a container, it cannot contain an operating system inside it. It cannot contain the bare metal inside it, obviously, because it is on the bare metal there is operating system, and on the operating system there is Docker, and inside of that you are running your code. So you can have this level of server inside of the container. Make sense? Okay. Okay. So if that is fine, then we can move to these. These are some not so important slides. So now we will move toward the more important thing, like the hands-on part of this whole architecture. Okay. And for that, let me just give you a brief overview of exactly what we'll be doing. Okay, so when you create an application, the most common problem that you guys face is that how to create the authentication architecture. So we'll be taking the example of that. Okay, so we'll be taking the example of key clock. Key clock is a sorry, I did a back panel. So key clock is a system where you can have these kind of facilities pre-built. Okay, so what is single sign-on? Single sign-on is like when you sign in on Google, you do not need to sign on YouTube. You do not need to sign on any Google application. So that kind of feature is single sign-on. There's social login, like login with Google. Okay, there is identity brokering, like communicating with different applications for identity. There are multiple custom themes, clustering for creating the scalability and availability, like we discussed. So this kind of facility can be provided by key clock. But when you try to install it, like you go for downloads and you see that there is, the whole system where you have to install the wildfire. So that is, so first you need to get the server part, then you will need to, install the wildfire into it. Then you will need to install this wildfire application into that, and that is also deprecated. Okay, so after that, you will need some databases, you will need to connect those databases, you will need to change those environment variables for you. So this is the system, that will really frustrate you if you need to create this whole system. And you'll be like, oh shit, if I need to install all these kind of things just for getting my authentication up and running, is it really worth it if I take the advantage of key clock? I need a very basic application. Probably I should really go with basic file-based authentication, or maybe the passport, like custom authentication of my own, right? But what if you could install everything from key clock and you didn't really had to do all this much of thing by yourself? You could simply get whole of this by simply a single command. Won't it be very beneficial for you? मजा आ जाएगा नहीं आ जाएगा? Okay, so we will be doing that. So we simply need to Google key clock Docker compose example. Okay, and we got this GitHub repository where they are providing Docker code compose example for our key clock. Okay, this is good. Let me just clone this repository so that it is easier for me to use this now. So for that, obviously we will need to go a bit on a step outside of it, and we will need to clone this level of this repository, so that because we cannot really clone a single folder from Git, we need to clone the whole repository. Okay, so let me open my terminal. cd, then zoom in, cd desktop, down desktop, and we will clone it. Git clone. That is nice. So we are cloning this whole repository, and after we clone this repository, we will find that we have a very awesome folder provided inside of this repository that we have here in this file open, and inside this desktop we have this on desktop we have key clock containers open. Okay, and inside this we have what? We have this Docker compose examples, and we have here our Postgres key clock example. And if we open this example, you will see that it is okay. It is a huge thing. It is a big thing that we are having here. कि बहुत कुछ हमने content यहाँ पे दे दिया है. But if we simply look at this, what this thing is saying that you have two services to run your whole system. One is the Postgres service, and second is the key clock service. Okay, and if you can create these two services and can bind them using this whole process, you can simply run your key clock. Okay, and even I will simply show you after this thing that how exactly you run your basic hello world and how do you get up to this thing and understand how exactly everything is happening inside this. But initially, so that you have a higher antho of what you can really create, I initially want to run this thing straight away. ठीक है ना, मस्त आ जाएगा उस चीज में that we will be running this thing straight away so that you have a higher antho for the things that is afterward. Okay, so for that what we simply do is that let me create a terminal for you and let me shift to this location. Okay, sorry. Let me shift to this location. So that is Docker Compose examples. CD, not here, CD, Docker Compose examples. And in here, we want to run the system. So we can say Docker Compose up. Okay, and which file I want to put up, that is this particular file docker, sorry, that is key clock postgres YAML. Okay, key clock postgres YAML up, and that's it. Now you can simply wait, and it is saying that it is taking a look. Okay, what we have. Okay, so there is one error: cannot cite service, denied, driver field programming, external connectivity and endpoint. Okay, port is already used. That is probably happening because we started this port for a separate application before some time. So what we can simply say is that we can change. This is also a good learning in this particular case. That if we have this application right now, we can simply change the external port for it. Okay. If we need to change, okay, 8080 is busy, we can shift to 8000. That's it, and we can simply run our code, and boom. Okay, so now it will be fetching up files and creating everything for you. And now the things which used to take a lot of time in setting up the whole entire system of login and password and everything, for creating whole that system, you do not need a lot of resources by yourself. Do not need to set up a lot of things by yourself. Wildfly and everything and database and everything is getting set up for you. Base structure is being created for you. You need to simply run this file, and everything, every container, everything is being downloaded and set up for you. Okay, so अगर ये सब कुछ हो गया, this thing is done. So after maybe a minute, obviously these kind of installation takes some time. So but this will happen in maximum a minute. So after that, we will be able to simply look up this thing on the browser and configure from there. So the basic thing is already done in this case. So there is one line from AVM is that इसके तो gulp and grunt पे use कर सकते हैं. Gulp and grunt are separate thing. So those are for automation of very basic thing like shifting of files and movement of files. Those you don't use grunt for creating a scalable database system. Okay, so that kind of system cannot really help in this thing. You said that okay, Circle CI. So Circle CI internally use Docker. So you are not replacing Docker when you are using Circle CI. Circle CI is a separate binding that use Docker inside it. Make sense? ठीक है, तो मतलब डॉक जो ये सर्कल सीआई और ये ट्रैवस सीआई, all these CI system use Docker system inside of them because they need continuous integration, continuous development, and for everything similar to that you need a container system. Please explain about the port in the case of so yeah, I will be discussing whole of the content inside of this. I'm just skipping it right now so that we can simply show that okay, this application is up. And after that, I will be coming back to this thing and explaining each and everything inside of it. Okay, so don't worry about it. So what we have here is that on our local host 8000, we have our application running. Okay, we have our administration console, and this administration console will be using the username and password, whichever username and password we have here. Okay, you have this username and password admin and corresponding to this password. Just 1 second. Username is admin and password is this password. Okay, here, login. Okay, so that's it. You are inside of this thing, and trust me, this is the authentication system we are integrating in our system. This is the some of you are very keen about competitive programming, so probably you have heard about uh, ICPC exam. Okay, so those people also use this key clock, and you can even find about more clients. So a lot of people, if you even talk about Red Hat. Red Hat provide license of this is the free version of this key clock, but the paid version, the licensed version of the system, the identity provider that Red Hat sell. Only the license of this application in the production in this corporate mode where they provide support and everything, they sell it for 24 lakh. So that is the I will say power of open source, that the product that they sell for 24 lakh, on the other hand, when they are building in open source, it is available for free for everybody. So if you can simply have that kind of understanding of thing, of using these kind of resource, you can really use these kind of capable resources for free. So you just have to learn these kind of things so that you have a better understanding and grasp of these things. Okay, so we have this admin console. If we want to change the login architecture, like I want to provide the registration as well, I want email registration, I want forward password, I want remember me and verify email and these things, I want to use SSL, I want user federation, I want maybe identity provider like login with GitHub, Facebook, Google, LinkedIn, Instagram, Microsoft. These kind of operations are available within this. Like I want to create a login with Google. So just I have to Google identity provider. I have to go there. Google credentials. Credentials. This is the credential page. You simply go there. You create a separate OAuth key. Maybe if I open this page, this thing will happen. Okay. So let me create a separate one for you so that you also feel comfortable exactly what's happening here in this case. So if I say that I want this separate OAuth key, this is like a web application. Next, add a URI, and let me add this local URI that is being shown here. Add URI, not this one, and simply create. Well, as simple as that. And now we have this basic client ID and client secret that we can copy from here into this admin console. Boom. And save. Done. Okay. So what if I have done this thing and now I create a logout, and now we will have a sign in with Google feature inside of this. Okay, so what I'm saying is that these kind of things are so easy to do in this feature. Sign in with Google, you just implemented that. If you just have to redirect your application to use key clock, and that's it, your application will be having Google sign in feature. If you can simply use Docker to set up your key clock, in that particular case, you will not be having to understand everything. You do not have to put that much effort in setting up the key clock. That is happening, and now you can run. Now you can have this Google sign in along with this thing. So isn't it great? एक बार I want that kind of info from you guys. To understand if feel okay exactly Google setup कितना easy होगा. Take a look. I'm putting up this Google sign in. This is prompting up with this thing, and I can integrate my account. So you might feel that this thing is not that much, but let me show you this thing. I created this. So just after tap, it will be saying forbidden. And because of what? ये forbidden क्यों है इस particular case के अंदर? Because now this added account, I didn't provided the default values of you can say admin. ठीक है? Forgot password will not work right now in this particular case because we haven't created the email setup. Okay, so if we say particular case के अंदर, if we are back on the login screen, just 1 second, let me log out. In this particular case, if we say about admin and password, we do not we haven't provided the sign up. Sorry, the previous on that page, the issue was that we didn't press the save button. Because of that, there is not forgot password at this page. So if we say admin and this thing password, and we go to that page and we sorry, that is just for yes, sir. Yeah. So the problem was in that particular case that in client registration and forgot password, we didn't put save. If we save that and we log out, now we have this new user and we have forgot password and everything. Okay, the forgot password is still not happening here because we haven't created the setup for email. That's it. Don't worry about it. Okay, so if we do this admin and we use this password, and let me just show you a better way of thing. One awesome thing in this particular case, that is that if we go for users and view all users, we have this particular user, this Anuj user with us. And obviously we can automate this for further process, but for this particular case, what we can say that we want to create a role mapping and we want to create this user as an admin user. So one thing is that you can do all of these things by coding, and the other way is that if you want for the beginner part of things, that initially I do not want I want all user to be basic kind of user and some user to be admin. Okay, and I don't want to code that part, so that much is easy for you. Okay, so if you want to create some basic roles and you can you want a platform where you can manually handle them, so that thing is already implemented in this thing. So like if this part is done, we can simply do what? This is done, we can say okay, log out. But now in this particular case, I will log in as Anuj, not as admin. I will log in as Anuj, but I will still be able to use this platform. Why? Because now this Anuj is also an admin. Okay, so this thing is creating that much of comfort for you in this whole system. Make sense, everybody? सबको मजा आ रहा है इस चीज में? Okay, so ये बहुत basic सा code is helping you in creating all this thing. Okay, so अगर ये चीज समझ पा रहे हो सभी कि Keycloak एक beneficial tool है जिसके अंदर इतने सारे features are available there. So now we can move to what? How exactly this thing is happening. So for that, I will show you a sample. EVM saying मतलब कि हमें auth पे ध्यान नहीं देना, डायरेक्ट अपनी ऐप पे ध्यान देना पड़ेगा. Yes, that is the benefit of these kind of applications. And this is not just about this was the one simple example that that of Keycloak. But the thought that I want in you guys is that you can use a lot of such kind of application which are pre-built, and you will not be needing to install and set up on your system by yourself. What you simply can do is that you simply import them using Docker. You can simply set up them and you are ready to go. You don't have to worry about those kind of things now. Okay, पूरा setup, पूरा environment variable change करना पड़ेगा, Java. हाँ, so the one more thing that you would have to worry about if you would have been running it by yourself is that Java, this wildfire system run on the particular versions of Java. So sometimes it happens that you are using the wrong version for wildfire, you are using the wrong version for Java, and in that particular case as well, there are some errors in wildfire. Okay, but now when you are using this Docker system, you are using the exact system of all the application, all the system that they are setting up for their whole environment. Okay, so you are having a exact copy of their environment, so there is a very less chance of failure. Okay, yeah. So basically all of this makes our life easier. Okay, and whenever you try to contribute in open source, generally what I say is that start working as a start using thing as a user. Okay, and for becoming the user, these kind of things are very important to understand that how exactly everything happens. That is very important. Okay, for that part, Docker is very good thing for you. And now if we take a look at this one, what exactly is this YAML file. So this YAML file is providing the services that you need to install. Okay, so we could obviously had a separate image for key clocker. If you simply want to run a Docker run on your terminal, you can do that as well. Like simply Docker run. I don't remember exactly what was the name of that, but probably it was this hello world only. Docker run hello world. It is not unable to find hello world latest locally. It will try to pull library.hello world, and that's it. It is running this hello world, and that's it. So this is the simplest way of running a Docker file. So when we say Docker and that particular name, like from Docker Hub, if we want to grab, sorry, I just pressed by mistake stop sharing. I will share again. Okay, so now I think it should be back to sharing. What I was doing, I was showing you Docker Hub. Docker Hub, maybe key clock. JBoss key clock. So if you simply want to run this JBoss key clock without any integration of database and everything, you could simply say this thing. Docker run from this JBoss repository, run key clock. That's it. And it will say that it is not able to find JBoss locally. It will get these layers which will create the image, and from this image you will create the containers. Okay, so this is what is happening. Okay, so it is downloading everything. It will run the whole thing, but now in this particular case you will not be able to configure database and everything. So the part that we said that in this session we will cover how to connect these kind of services to create something meaningful that is happening using Docker Compose. So what is the meaning of running a Docker file? So when you say that is the meaning of running a Docker file? Is key clock available for free tier on GCP? What I'm saying is that key clock is free for everybody. In terms of open source, key clock is free for everybody. When I said about 23 lakh, that was the enterprise version of the same code where they provide the support. If something get blasted, they will be there to help you. That's it. So if you think of community support, there are two versions of all these open source architecture of Red Hat. There is a community support and there is enterprise support. So if you know about open source, if you have been involving in the open source community, you can generally go with the open source community support, and those are always free. So you don't have to worry about the pricing. Make sense? Okay. Okay. So in this particular case, what we can see is that, okay, we are using Docker Compose version 3. We are putting this volume. And what is the benefit of this volume is that, whenever we are saving this Postgres data, we are saying that this, whenever we start back again, our content will remain there. If I remove this part and this volume, so whenever we restart our Docker system, it will be a fresh system. Okay, if I remove this line and this line, so now if I stop my system and restart, every time I restart, there will not be any user storage or anything, because we have totally disconnected the local storage from our containers. Okay. So we do not want that. We want our system to have the same storage again and again. So because of that, we will have this volume attached. Makes sense? The volume is the storage part. Storage can have two kind of connectivity. One is external, we can say external folder connectivity, where you are putting dumping whole of the content to a particular folder, or there is volume connectivity, like in terms of this data. So for that, you will not be able to exactly have the folder in which you are dumping your content and taking back, but it is as compared a simpler version. Okay. Then you are using two services, Postgres and Keycloak. You could name them anything. You don't have to worry about that. But when you provide the name of image, you have to provide that very correctly, because this is the name that is we are grabbing from Docker Hub, like this square.io/keycloak latest. Okay, so we are not using the JBoss version of Keycloak. We are using the modified version of Keycloak, which have pre set up things to connect with databases and everything. So this one is a bit modified version of the JBoss Keycloak. So now you can simply provide the environment variables that you need to configure your behavior of Keycloak, and that will go perfectly fine. Okay, so if you have these environment variables, then you have this thought that how exactly we are connecting these Postgres system and this one system. Okay, so what is happening is that we say that this particular service depends on Postgres. So because of that, what will happen is that our Docker system will bind these two applications, and these two now have a network connectivity. So that means what? That now these two applications can interact with each other. And what we are saying is that this service have an external port connectivity, and that is internally it is 8080, but externally it is 8000. Okay. So what is happening, because these two are connected, we do not have to expose any of the port from Postgres. और तुम लोग पूछोगे कि इस चीज का बेनिफिट क्या है? What is the benefit of this? कि Postgres से port expose नहीं हो रहा. So can you really from outside, any device that is, maybe even if I provide you my IP or anything, or even if my system had been on the public location, because this network of Postgres is in contained environment, you cannot really directly, attack on my Postgres, because now it is virtually available. It is not available on the public port. It is virtually available to Keycloak only. Keycloak के अलावा किसी को available नहीं है. It is only available to Keycloak. And because now we have a public port binding for this Keycloak, now this 8000 can be used from outside, and this internal port can be anything. So now generally what happens is that when we run our application, we have to provide the port, and we have to also provide the code, like this port may shift or this port may change. But now when we are using Docker, we can simply say that we do not need to change the value of our port. We can change the external value of port. Internal value can be anything. So I'm not putting too much emphasis on what exactly port is, but it is like a public location, public point on your IP, which can separate exactly which application will listen to what. Okay, so that kind of thing is very important to understand. These two port. Okay, so what we can say is that whenever you provide this kind of information, this port or anything, so the first value is the external value, and the second value is the internal value. So internally, our Keycloak is running on 8080, but externally, our Keycloak will represent to look on to work on 8000. Like AVM word said, in JavaScript, we have process.env.port, but that is receiving the value of the port variable, so that from environment variable. This is something very different. It is right now saying that what exactly to use when we are running. Okay. Okay. So if you're comfortable with this thing, so you can totally say, okay, this thing is here, and now if we want some kind of configuration on our system, okay, so maybe What I simply want to say that maybe I want to remove from this login page, from this key clock login page. I only want this Google. I do not want this part of the system. So how exactly we do that? We want some configuration. So what simply we can do is, with the help of Docker PS, we have the list of our processes that we are running. And from this, we can say that we want to connect with this Docker image. So we can say Docker exact and execute iterate interactively. Docker execute interactively on this image, and the command that we want to run is on the bin. We want to run the bash. Okay, so let me just put this back onto you. How exactly what exactly is happening right now? We are saying that we are running a Docker command. We're executing on interactively with this container, okay? And we are running this particular command on this container. So what exactly it is doing is that it will show us that it is with bash, with the help of born again shell, it's connected to this particular container. Okay, and now we can traverse into this container. Okay, so we can do anything inside this container right now. Like if we say pwd, it will tell us that we are in the root of our this container, and then if we can go inside this opt and maybe jbox and maybe key clock and themes, and this is the if we say present looking directory, this is the theme list of our support system. If we go for themes, and then we can show ls. So we have different themes here. We have base theme, we have key clock theme, we have key clock preview theme, and these kind of things we have here. Okay, so if we want to copy all of this content outside, and we want to maybe provide this value to change some configuration with us. Okay, so what we can do, we can simply say, okay, do what for us? Let me just copy these, Docker CP, copy these values. For Docker CP, we will have to go outside. So we will need to, quit from here. Just a second. We will just open the other one. Let me connect the second one. And hit that. Docker CP from this Docker. I want to copy this content to a desktop. That is our desktop. And container colon source path. Okay, ठीक है. So we just have to bind it. Okay. So there was a mistake that I was doing. So this is the destination path. So it will work same as what happened to the inside of them. Yeah. So desktop. There's probably some mistake that I'm doing. Dr. CP. Destination. And boom. Okay. So now we have this themes folder outside, and this themes folder contain all of the themes inside of our system. Okay. So if we have these themes and we want to copy this one, okay, the base theme, and from the base theme we want this login, and this login we want to change what? This login.ftl file. Okay. So what we can simply say that we want our themes to be connected. Okay. In the system, we want our themes to be connected. And for that, if we here create a folder, like here, we are running here, and we say that we want to create a folder for themes. And themes, we have a folder for like happy. We want to create a new theme happy. In this new theme happy, we have this separate folder for login within this folder. Oh, sorry, I created this as a file by mistake. Delete, move to trash. In themes, we have new folder happy, and in this folder, we have new folder login, and in this login folder, I want to copy my file. That is from login. I need to copy this login in FTL. Right click and paste here. And open it in folder. That is sorry. Login, paste this. ठीक है, login.ftl. ठीक है. So अभी मैं तुम्हारे को एक कस्टमाइजेशन दिखाना चाहता हूँ. For that, what I can simply say कि when I rerun, now I will find this theme, and in this theme, let me change some small thing. And that is here on the top. I want even if whatever happened, I want to change something bigger. This is the text form. Let me just remove the whole form for you. Don't worry, we will just remove this form for you. This is the entire form for the left side. Okay, we will remove the whole form. Straight away making a big change. Okay, see the form जो उड़ाना था, we remove it. ठीक है, सीधा पासवर्ड वाला फॉर्म उड़ा दिया. सिर्फ अब हमारे पास में सिर्फ गूगल लॉगिन है और दूसरा पार्ट नहीं. बढ़िया. एंड नाउ डू व्हाट, हमने वापस गए एंड हियर हमने पुराने वाला कंटेनर बंद कर दिया. एंड वी विल गो विद द रिपीट. सॉरी, लेट मी जस्ट डू वन थिंग दैट आई फॉरगॉट कि हमने ये वॉल्यूम बाइंड नहीं करी. ठीक है, so we also need to bind this volume to get this content. Okay, so for this content what we need to do कि हमने बाकी सब चीज चेंज कर दी, but like we had volumes in this case, we also have to have volume for our this one as well, and this one. Okay, and we need that we need to bind our this themes folder, this themes happy login to the internal happy login part of opt. So that is in Teams happy login or Teams.happy is connected to which one? That is slash opt slash keyclock slash theme slash happy. Boom. Right? So if we connect this thing, we are connected volumes, and now we can simply say what? That now we want to rerun our system. What exactly is happening here that we are customizing our login page. So what I'm simply saying is that we have copied the content. We are now, kind of replicating our own version of key clock so that we can alter its, way of behaving. Like we want to change the login page to something. So we can do that. That is the customization that key clock provide to us. Okay. And I'm not getting the motive why I am learning this. I mean, what is the purpose we are going to use specifically? Okay, so that is a very good question. So what I'm really showing you is that how can you use any Docker image and how can you get the content from it? How can you bind new folders to it? So you can customize anything you want inside a particular Docker, and you can use it as a a separate software installation. So generally what happens is that when you talk about containers, when you talk about Docker, you really feel that it is kind of a pre-built thing that you cannot change anything about. But that is not true. What generally happens is that you can change anything about a Docker image. The way of doing that is different. But the benefit you have already understood. What is the benefit of running a Docker system? So that when you kind of grab this code and you provide it to somebody else, first thing is it will consume less resource. Second thing, it will be easier to get up and running, and there will not be a thing like what generally you do is that कॉलेज के फाइनल ईयर प्रोजेक्ट के अंदर क्या होता है, तुम बनाते हो चीजों को, तुम फाइनल दूसरे बंदे को देते हो, एंड यू विल बी लाइक सर ये मेरे सिस्टम पे तो चल रहा था, आपके पे चल नहीं रहा, पता नहीं क्या इशू आया, मेरे सिस्टम पे तो चल रहा था, है ना? बिकॉज डॉकर इज very different from this whole architecture. Docker is like it create the whole image and it use that same architecture. Because of that, it will not happen that something run on the one system and doesn't work on the other system. This makes sense, Ram Vilas? Okay, so if you understand this thing, then we can simply go back to our local host 8000. And in this case, now we can again open our admin console. And because we can log in with Google, we came here, we log in with Google to our Anushka account. Okay, and after you log in using our Anushka account, we will go to the section where we can change our theme. Okay, in our this page, we can go for the theme section, and where will we see that now we have this happy theme here. Okay, and I save it and I do this logout. Sorry. I think I did something wrong when creating this sheet. So yeah. So I probably, because I didn't want it to, copy everything. So I did some mistake in that. So that corrupted some content. But generally what exactly should have happened in this particular case is that now we should have got the customized version. So, let me just see if we did something wrong in here. Slash themes. Oh yeah. So we had one slash here, but we do not have any slash here. So that will create an issue. And if we stop this thing and we start back again, it will work totally fine. There can be two cases now. Either we will have to put slashes on both ends, or we have to remove slashes from both the ends. So probably both should work, but let me check, because this is about the customization. So sometimes you may have to change a few things a bit. Sometimes. Okay. तो मस्त चीज है ये, थोड़ा सा तुम्हारे को तो थोड़ा सा पुट करना पड़ेगा इसके अंदर, बट द थिंग इज दैट whenever you are contributing to any open source software, so the first thing that you have to do is you have to set up the environment, and these kind of things, if you use for setting up the environment, can really help you in getting up and running in very small amount of time. That can really help you in a lot of things. Okay, so we are back up again, and we can now, just in a second, we can check on our browser that if things are running or not. So, any question till this point? सही लग रहा है अभी तक? There's some issue. Let's not worry about it. Okay. Yeah, the next thing that we can really check to see if everything is according to our plan or not, that we can, inside of happy, we can copy paste whole of the code from here. The whole system that we are using is the base property, and now we can change inside this login. In the login.ftr, we can remove this. If so, is there any question from you guys? सही तो लग रहा होगा, मजा तो आ रहा होगा, चीज तो तोड़ है. सुब्रमण्य भाई यार, पूरी की पूरी रामायण खत्म हो गई, कह रहे सीता किसका बाप था. व्हाट इज डॉकर? डॉकर इज व्हाट? Docker is a tool that can help you create containers, and container is doing what? Container is helping you, you know, build the whole cloud system. You can simply say. Okay. Don't worry about it. If you are unsure, let me just yeah, let me put let me help you with a recap. Before that we can go with this thing that we have built this custom page. We removed some content, and because of that we have this basic login page, and in which if you click this login, it will help you with the same process. This is not exactly the page you were having initially. We have customized it and removed some padding and everything from it, but now if you click on this login, this will behave exactly as the previous one, and you could provide any HTML or anything to it, and that would have worked perfectly fine. That's it. Okay. let me just click on it, and it is working at the same login page that we have initially. So you can go with Bootstrap and create any login page for this whole process. Makes sense? So this is the thing that I'm telling you, that with the help of Docker, you can customize this content. Okay. So what does this mean? By running a container, we are running a server. This is not every time that when we are running a container, we are running a server. We could create container for anything. A container can be about database, a container about any process or anything, any automation. A container is not any moment have to be, particularly about a server. A container is simply a virtual machine that do not need operating system. It is like a virtually created instance of image. That's it. So when you talk about cloud, cloud is like collection of these kind of containers. That's it. And those containers can interact, cannot interact, can do something individually, can help each other do things. So that's it. You do not have anything. You could create a container that is very specific to storing data. You can create a container that is very specific to computing. So this is the whole system that you go with. Yeah, so that is ACM ICPC website. Yes, Javandeep. So ACM ICPC use Keycloak. A lot of other use Keycloak, but they kind of change the theme as well. ACM ICPC do not change the theme, so because of that, you see there. Okay, so for rest of the things, as our session have been approximately 2 hours, and that this is a bit heavy content for 2 hours. So what you guys can do is that if you still have any doubts, so we have our Discord channel in the description. You can put your question on Discord, and I will be there to help you with all of that. So don't worry about it. And one more thing that I will put, let me put, ma'am, can you please stop my screen? Yeah. So I will put the link to the YouTube session that we have tomorrow. Uh, just 1 second. Click focus and this. Yeah. So tomorrow we have a session with Yanni. And this, oh, sorry, not here. I will not be able to put link with this account. Switch account, focus, and okay. So Yanni is an awesome guy. You should totally uh, see that seminar. That is, a fabulous piece of work that we will be doing with him. He is, if you take a look at his profile, he is like he have contributed to Facebook. He have done so many things, and he'll be helping you understand how to build your profile. So we have this session tomorrow at 6 p.m. IST. You can check that. You should take it as a mandatory thing. It is something that you should go with. Okay, so I have provided the link. Just take a look at it, and this will be a fabulous session to attend. Okay, so and subscribe the channel if you really want these kind of session. You want to have continuous updates on that. Okay, so that's it for today. I hope you guys loved the session. You guys have probably got a lot of content from all of the thing that we have discussed today, and I want to see the cheer that you guys are facing right now, the enthusiasm that you have right now. Is there a Docker for there is a Docker for approximately anything. There's Docker for anything. If you are using any open source software, you approximately have a Docker for it. Okay, so for mailing systems, for even if you want to have something like your own GitHub server, so you do not have Docker for GitHub, but you have Docker for GitLab. Can you please share the screen? So GitLab, Docker Compose. So you have GitLab Docker images, you can run them, and you can literally set up your own GitLab installation. So GitLab is like alternative to GitHub, but GitLab is completely open source in terms of a lot of content. So you can set up your GitLab setup. And if you want your to run it on server so that your whole company can use GitLab and you do not have to publish or do anything outside your system, that will help you. So obviously GitHub do not have their own system on Docker Compose on in terms of public content. Probably they also use Docker, but they probably use personal images. They do not want to publish that when their code open. Okay, so that's it. You can use a lot of content. You can use a lot of things in Docker with the help of this thing like GitLab and a lot of things. You can install, you can use any database. You can approximately, which is open source, is on Docker right now. Don't worry about it. Okay. So that's it. See you guys. Bye.